So today I will record with your class. You got two papers. So one paper is a practice worksheet. Usually I make those practice worksheets purple. A practice worksheet means quiz is coming. So ideally, I like to have the practice the day before the quiz. Sometimes practice is on quiz day where we do half class is practice and then the other half is quiz. So the quiz is like a review. Sorry, the practice is like a review for the quiz. So you get a review for a test and you get a practice for the quiz. I think I've said before, I'm not really a gotcha for the quiz. So I don't want to trick you. I don't want to put problems on there that you've never seen before. So the practice is really important that you do and you take seriously. I have solutions to the practice. So when you work the practice, these are not like a secret. I want you to know what the right answers are because I want you to fix them before the quiz. So a lot of times I'll take whatever the solutions are and I'll tack them up. And mainly when we grade those, because I'm giving you the answers, it's just a really minor grade and I'm looking to make sure that you have work to support the answers. So we don't really grade the practice because I'm giving you the solutions. So at some point today, I don't even care if you take pictures of the solutions if you don't have time to work them all, because like I said, they're not a secret. I want you to have the answers. I also have all of the work worked out. So if you look at one of those and you're like, ooh, I don't know how she got -7, then come up and you can compare your work with me. So this is what we're doing, but this is at the end. So this is review of all the stuff that we've done before. But what we are going to do today, and the stuff that we're doing today, this isn't on the quiz, but I still have to fit it in so that after the quiz, we can start new stuff. So the stuff that we're doing today is graphing. We're going to remember how to graph lines. And then I'm pretty certain you've never graphed inequalities before, so that will be new. So what we're doing is we're just remembering how to graph lines. This shouldn't take very long. So we're just going to do some examples on the front of graphing lines, and then on the back, we're going to graph inequalities. And so we're going to kind of look at the differences of how is graphing a line different than graphing an inequality because they're similar. First thing that I want to point out is this, y equals mx plus b. Does anybody remember that? Oh, also, before we get started, and you guys are amazing. Like pretty much everybody has already put their phones away. Y'all are great. If you haven't already, make sure you put your phones away. We got to listen. This is how we learn. If at the end of class, when you start working on your practice worksheet, you want to put your earbud in, you want to listen to some music, I don't really care. But right now we're taking notes, so I really need you to pause what you're doing and I need you to focus and pay attention. Y equals mx plus b. Does anybody remember what these parts stand for? What's the m?
Slope.
Very good. Yes, slope, slope, slope. So the m is slope. And the b, what does b stand for? Nope. Yes, the y-intercept. B would be a base in like a formula for area or something. So the y-intercept. And one way that we talk about slope is rise over run. Yes, rise over run. So now that we've written those down, do you guys kind of remember, even if you didn't remember initially, we remember that slope is m and y-intercept is b. When we go to graph these, it's kind of weird because we're going to do them in the opposite order. So the first thing that we're going to do when we're in slope-intercept form, which is the easiest to graph, we're going to do the intercept first. You got to go find that. And then from the intercept, we will do the slope. So graphing is really two steps. You go find your intercept, and then you do your slope, whatever it is. Also, lines are symmetrical. So when we go to graph, we're going to be graphing from the y-intercept, so if I am the y-intercept, I'm going to put my point, and then I'm going to apply the slope, and I will always get this half of my graph, whether it's up or down. I'll get this half. We're going to use symmetry to go the other direction. So they'll always be symmetrical. So if I have to go up 3 and over 2 to get this half, I go down 3 and over 2 to get this half. So we'll use symmetry to help us get some points. The way that I grade graphs. So I know that we don't do everything perfect. That is okay. But if what you do is you plot points first and then you graph, if your line isn't exactly on all of the points, then you're going to get credit. If it's like right to the side, you'll get credit. If you just eyeball it and you draw a line, but you don't go through 3, you go through 3.5, that you will lose points. Not a whole lot, but you will lose points. So as long as you plot points, you're pretty safe. Again, I mentioned if anybody wanted one of the protractors to make straight lines, you don't have to. You can make a straight line without one. But if you want to get up and get one, you can. Does anybody want a protractor or a straight edge to draw your graphs? You can come get one. You can get one. They're up here. They're right here. They're these little, yeah. Yeah, so if anybody wants a straight edge, you don't have to. You can draw a straight line without one, that's fine. But if you want a straight edge, then you can grab one. And also, for me especially, doing these on here, usually when I'm drawing lines, I can take and I can turn my paper and then I can make a line. On here, I can't really turn it to make my line. So sometimes my lines don't match up or they're like shaky. Don't judge me. I'm going to have my points plotted so that you know where it should cross. You know where it should cross. Let's get started. So the first thing that it says is that I am going to plot the y-intercept. So that's where you cross the y-axis. These are labeled. This is x and this is y. This is my y-intercept. It says +2. So from 0, I'm going to go up 2 on the y-axis, and I'm going to go put a point. For my slope is rise over run. When I look at the slope for this one, it just says 3. So if it's not a fraction, or if you struggle with just having a whole number, you can always put it over 1. Because 3 is the same thing as 3 over 1, right? Yes. So this says that, and it's positive. So if it's positive, you go up. So I'm going to go up 3 over 1. So from my point, I will go up 3. So 1, 2, 3, and then over 1, and I will put another point. If I went up 3 and over 1 again, I'm going to fall off my grid. So I don't need to do another point that way. But I'm going to use symmetry to build my line the other direction. So from my y-intercept, if I went up 3 and over 1, then I need to go down 3 and over 1 to put another point. And I'm going to do that again a few times until I run out of graph. So I have plotted my points. Now all I got to do is draw a line through them. Oh, where did Mike? There we go. So this is where I'm going to try really hard to make it match up. Again, don't judge me because mine is really hard to do like this. But you're going to draw a nice, beautiful line through those points. And what's really important, and so you might want to make yourself a little note, don't forget the arrows. You need to put an arrow on both sides. After that first test and you lose a point, so like let's say you were going to make a 90 and you made an 89, you're going to hate me when I take off a point because you didn't put arrows on the ends of your graph. Put arrows on the ends of your graph because you will lose points. Any questions over graphing this first one? Nope. All right, let's graph the second one. The second one says that our y-intercept is 1. So I'm going to go find 1. So up 1, and I'm going to put a point. For this one, I have a negative slope, so that means I need to go down. So from my y-intercept, it says that I will go down 2 and then over 3. So I will go down 2 and then over 3. And then I will put my next point. And then I'm going to do the same thing the other direction. I will go up 2 and over 3. We good? I'm going to draw a line through my graph. And make sure that I put arrows. Maybe the thicker line is better. Example 3, I'm going to do the same steps. I'm going to first go find that y-intercept. So that is at -3. So from 0, 0, I'm going to go down 3 and I'm going to put my y-intercept. For this one, the slope just says negative. It just says negative, really. So I can add numbers there if I need it. It's actually -1/1. So if that helps you, go put them there. So this one says it's a negative slope, so it's going to have similar appearance as this one. It's going to face down. So it says down 1 and over 1. So I'm going to go down 1 and over 1, and I'm going to keep doing that until I run out of graph this way. And then I will go up 1 over 1 to make my graph that way. All right, my line kind of jumped a little bit, but because I have all my points plotted, I am good. Please do not forget your arrows. If you don't have arrows, you will lose points. So far, either thumbs up or thumbs down about graphing. Thank you. Thank you. Okay, so we're going to do the next one. The next one is a little tricky because there's no y-intercept. Does anybody know what it is if it's not there? So we're going to think about it just for a second. What number can you add to something and you don't change it? 0. So you can add 0 to anything without changing it. So if it's not there, it's 0. And the reason why on this one, there was no number there, the only number that you can multiply without changing it is 1. So if it's not there and you're multiplying, it's a 1. And if it's not there, if you're adding or subtracting, it's a 0. So for this one, if you want to add that on there, you can. That means that your y-intercept is right at the origin. So the origin is that point where the x and the y-axis cross. So that point right in the middle is called the origin. That's the center of your graph. That is the origin. It is 0, 0. For this one, I have a fraction for a slope. So it tells me that I'm going to go up 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. And I'm going to put a point. And then I'm going to do the same thing the other direction. Then I'm going to connect my dots. Oh, that one was much better. What is different about example 5?
We don't have a y.
We don't have a y. What about example 6?
We don't have x.
We don't have an x. So here's the deal with those. If you don't have a y or you don't have an x, that means you're only using one of the axes. So here's the way that you draw either the x equals or the y equals equations. When it's x equals, you chop through the x-axis. So if the x-axis is like this, then you have to chop through this way, wherever that number is. When you are a y equals equation, the y-axis goes like this. So you chop through wherever the number is on the y-axis. So y equals equations chop through this way, and then x equals equations, they chop through this way. So we're going to take this one and it says x is equal to 2. We'll then go find 2 on that x-axis. It's right here. And along that x-axis, you can put points up and down. It doesn't really matter where. It's just all along. And then I'm going to draw my line and it chops through the x-axis. As a side note, for a vertical line, if we thought about what slope is, because slope is how far up you go and how far over. So for this one, if I asked you what the slope is, how far up do you go? Forever. How far over do you go? You don't ever go over. So since you don't ever go over, and however far you go up, it could be 7. You could stop at 7, but how far over do you go? None. So you're dividing by 0. And when you divide by 0, it's undefined. So if you want to give yourself a little note, slope is undefined. The slope is undefined when you're an x equals equation. So vertical lines, slope is undefined. For the y equals equation, we're going to do the same steps, but since it's y equals, I need to go find y is equal to -1. So that's going to be along the y-axis. So I'm going to go down here to -1. And a y equals equation has to cut through the y-axis. So I'm going to put points this way. So you just need a few points along the y-axis. And then I'm going to connect dots. For this one, if I wanted to tell you the slope to get to my next point, it could be any of these points. How far up do you go? None, it's 0. How far over do you go? Well, to get to my next point, I went over 2. So 0, one way you can think about it is if you have no cookies, how many do your 2 friends get? Nothing. So this is this one is 0. So the slope for this one, slope is 0. So there's a difference in having an undefined slope and a 0 slope. One thing that you might want to do right underneath this, along that little line that you have on your paper, don't forget arrows. That means when you're drawing your lines, don't forget those arrows on the side. Some of you are going to forget the arrows and you're going to be mad. Don't forget the arrows. Take a moment and you're going to try the last 3 on the page. In fact, I will give you 3 minutes. I don't think it should take more than 3 minutes, but I'll give you 3 minutes. Let's see if you can get those last 3. As you get them, kind of look around, somebody next to you, make sure that your graph looks like their graph. So try those last 3 on your own. There's the pestle on the back hole. After we're done with this worksheet, if you want to come and check yours with mine, if you didn't have anybody around you or you don't trust them, then come check yours with mine if you would like. Yes, ma'am. Are you wanting to check? Yes. Good job. And if you want to come check, you don't have to come right now. You might come at the end when we're working on the practice. That's fine too, if you're not completely finished.
So each time it's negative, it goes on this side, right?
When it's negative, you go down.
All right.
Before we move on, I need you to stand. I know that you think these things are silly, but I need you to stand. This one is an important one because we're going to think about slope. So stand up. And you kind of have to spread out for this because you're going to be using your arms. So spread out so you don't slap somebody in the face. You're going to stand up and you're going to spread out so that you don't slap somebody in the face. So what you're going to do is you're going to show me these things with your arms. And the first one is a positive slope. So if you're doing a positive slope, your arms look like this. So you can look on the board to kind of help you, but your arms look like this. That is a positive slope. Good. So you should be doing the same motion as everybody else. The next one that we're going to practice is a negative slope. So a negative slope, it goes in the opposite direction. And we read books from left to right. So from left to right, you're going to point down. Yeah. Good job. The next one that we're going to do, because on the back side of our assignment, we are shading and we're graphing inequalities. And so when we graph inequalities, we have to know where to shade when we do greater than and less than. So when we do greater than shades up and to the right. These are both positive. So it's positive y and positive x. We shade this direction. That's kind of like the inequality symbol. We shade up and to the right. When we shade less than, you are shading in the negative parts of your x and y. So negative x is that way, negative y is that way. So we shade down and we shade to the left. These are where the negatives are. So those are less than. Don't sit down yet. I would like for you guys to show me a negative slope. So you should have right hand down. That's a negative slope. So if you didn't have it right, fix it. Show me negative slope. You should be pointing the same as everybody else. So if you don't know, look at what everybody else is doing. Good job. You can't feel stupid. Everybody's doing the same thing. So show me where you would shade if it is less than. You're shading down and you're shading to the left. Down and to the left. So if you didn't know where to do it, look at everybody else. Down and to the left. Shade down and to the left. Show me positive slope. Positive slope, we read from left to right. Positive slope, you're pointing up with your right hand. Show me where you shade if you are shading greater than. Up and to the right. That's where positives are. Okay, it's important that we know where these things are and how to do it. So you can sit down and we're going to do the back side. Before we get started, to graph a linear inequality, it is very similar to graphing an equation or an equality. But you have to think about two extra things. And so the two extra things are, is it solid or dashed line? And are you shading above or below? So this is the same idea that last class when we were graphing the solutions, we had our circle and we had to decide was I shaded inside or was I not? And I had to decide, was I shading to the right or to the left? It's the same two concepts, but now we're doing it with a linear inequality. So first, is that line solid or dashed? Is that line solid or dashed? And do you shade above or below? We're going to add some extra words to above and below. When we shade above, it's also to the right. And we shade below, it's also to the left. So this little table that I created, we're going to show what these things mean. So solid versus dashed. So solid, it doesn't matter which symbol that you have. It's the symbol that has the line underneath. So you could be less than or equal to or greater than or equal to. So if you have the line underneath, it is a solid line when you graph. So whenever you have the solid line underneath, you make a solid line when you graph. If you are dashed, it's just because you have greater than or less than, and you don't have anything underneath. So you need to have holes. So it's pretty easy when you graph and it's a solid line, it's going to look like a solid line. Now keep in mind that line could be tilted in different ways, but it's a solid line. When your graph is dashed, it needs to look dashed. Now you still put arrows on a dashed line, but it needs to look dashed. Also, when you graph something and it is a solid line, solid lines, you can include any points on that line are part of your solution. So this is points are included. And remember that when you are dashed, the points are not included. So the next two columns, we're going to talk about that shading. Where do you shade? So if you are shading above or to the right, it's because you had a greater than or a greater than or equal to symbol. So the symbols will, the way that they're facing tells you whether you shade above or below. And then if they have the bar underneath, tells you whether or not you're dashed or solid. So we also shade below or to the left. And those are when you're less than or equal to. And so what did those look like? Well, I am going to draw, and I'm just going to make them solid lines, okay? It could be dashed too, but I could have a positive slope or I could have a negative slope. And for my, same thing for below, I could have a positive slope or I could have a negative slope. You could also be horizontal or vertical lines, those work too. So what does it mean to shade above? So these can be kind of confusing to some students. Let me see if it'll let me get another color pen real fast. So to shade above, it is above or it's to the right, or it's kind of both. It's above and to the right. So when you shade above in your positive line, you're shading right here, That's where you shade. You're above and you're to the left. Sorry, above and to the right. If you have a negative slope, you're still shading above and to the right. So this one is usually confusing for students to know that, okay, well, above is right there. So if you're graphing something and you're shading below for less than, it's below and to the left. And that is shading less than. It's also below and to the left.
So when he's right, he's like in the up, and when he's left, he's down.
Yes. So if you have a horizontal line and it's greater than, well, then you shade up. If it's less than, then you shade down. If you have a vertical line and it is positive, or sorry, if it's greater than, then you're going to shade to positive numbers. So you shade on the positive side. And if it's less than, you shade to the left because it's where negative numbers are. So that's how you shade if you're a horizontal or a vertical line. So let's graph these. Your first step is always the same. You got to go plot those points. Okay, so our first step is still the same. You go plot points. Where's my? So for this one, y is greater than, and that is no number next to the x, so we know that it's the same thing as a 1/1. For this one, that symbol, it tells me that I'm going to have which type of line?
Shade, dash.
Dashed. I'm going to have dashed. I'm just giving myself a little note. It's going to be dashed. And this symbol, does it tell me that I'm going to shade which one, above or below? I'm going to shade above or right. All right, so those are notes to myself because I don't want to forget those, but now I'm going to go plot my points. So it's still y-intercept first. So this says -5. So I'm going to go down -5 and I'm going to put a point. My slope is positive, so I know it's going to have that positive slope. It's got to have that positive slope in my head. I know what it needs to look like. So this one says I go up 1 and then over 1. Up 1 over 1, up 1 over 1, up 1 over 1. You want to save yourself some time. It's the same thing as going up 2 over 2. So I've got myself some points there. Once I have the points, I have to be careful because I don't just draw my line. Sometimes you do, but for this one, it needs to be a dashed line. So I need to make sure that when I connect the points, I make it dashed. So it's going to be a dashed line. And then it says that I'm going to shade above. And when I shade above, I can go up and to the right. I'm going to shade all of that. So all this over here would be shaded. Yep. Yep. Yes. How do I know that this is above? Because I gave myself a little cheat sheet. So it's above that line. If I go this way, that is all stuff that is below the line. So one way you can think about it is like this, because this is what stumps everybody, is knowing where to shade. If I am like this, do we all agree that above is that way? Yeah, okay. Well, if it's that way and I just tilt, it's still the same direction. So if you need to start from a horizontal line and you're like, okay, well, I'm shading above, you can kind of do that mentally in your head. Okay, I am shading above. And for this one, my line is a positive slope. So I just tilt and that tells you where you shade. Does that kind of make sense? Yeah, so if you guys need to, if it's tough for you to remember, start with a horizontal line. If you're starting with a horizontal line and you know you need to shade above, think about pointing above. For this one, I have a positive slope, so the line shifts to a positive line. I'm still shading in the same direction, so it's up here. Does that make sense? Okay. Because I know that that shading above and shading below part can be tricky. When I look at my next one, I can give myself a note. What does that symbol tell me to do? I'm going to be a solid line. Yes, I will be solid. And it's a less than symbol. So I need to shade below. Below. So I'm going to take a look. It says that my y-intercept is at 1. So I'm going to go put a point at 1. For this one, ooh, my slope is negative. So I know that reading from left to right, my slope needs to go down. And for this one, the slope is -4. And if you need to, you can put over 1. So from here, I'm going to go down 4 and then over 1. And I can do the same thing till I run out of graph. Now I'm going to connect the dots. And for this one, since I'm in solid line, I just connect it. It's going to be a solid regular line. Oh my goodness. We're going to pretend like that matched up better than it did. There, maybe that's better. So there's my solid line. And again, if it is tricky for you to know where to shade for below, you can start with this horizontal line. It's a horizontal line, and the symbol says that I'm going to shade below. So starting from a horizontal line, if I shade below, we all agree it's down. For this one, I have a negative slope. So if I just shift my graph, it's going to shade that direction. Are we good on these two examples? Good-ish. It's kind of a new thing. The next two are the x equals, y equals. So this is more of when you shade to the right or to the left, or really up or down. For this one, my symbol, it tells me that I will be solid or dashed. Dashed. And then That one is a less than symbol, so I need to shade below. For question 13, does my symbol tell me solid or dashed? Solid. And above or below? Above. So for question 12, it's y is equal to -3. So I got to go find -3 along the y. And I can put a few points because I'm going to go that way. If this one is dashed, I need to make sure that I make a dashed line. Don't forget your arrows. And it's pretty easy to see below because below is below. I'm shading below. So for these, the solution is everywhere that you shade. So if I asked you a question like, is 3 -6 in your solution? Yeah, it's in the shaded spot. But if I asked you, is 3 -3 in the solution? The answer is no, because it's on a dashed line. So the things on a dashed line are not included. So everywhere that you shade is included. And if you have a solid line, anything along the line. For this question, it says 2. So along X, I'm going to go find 2. I'm going to put a point. And then I'm going to make a few more points because I'm going to chop through the x-axis. This one is a solid line, so I can make a solid line. Don't forget your arrows. And then this one says above, but you can't really shade above. So for this one, when it's greater than, you shade to the right. You shade everything that's to the right because you shade on the bigger side. The bigger side is this side. For this one, everything in the shaded region and everything along the solid line is part of your solution. You have 3 problems to try on your own. That is all that we have today. You're going to finish the practice worksheet and you have a quiz next class. The practice worksheet is practice. It's like the review.